Hi everyone, we are getting so close. Congratulations on making it this far. We're going to cover section 6.2 and 6.4 today, factoring trinomials. Now if you watch the video tied to the other PowerPoint, it sings a song about shortcuts to factoring trinomials. So our shortcuts, again, these shortcuts are just there because they make your math a little bit easier when we actually get to factoring. So learning these will just take away a step that you don't have to think about. When you're factoring, you always want to look at the second operation. So the operation that's tied to C. This operation will tell you what your answer is. Anytime you're factoring a trinomial, you're always going from a trinomial to two binomials being multiplied together. In chapter 5, we started with two binomials and we multiplied them to a trinomial. So we're just working backwards. Anytime you have a positive as your second operation, this first operation is going to apply to both binomials. So if I have two positives, I'm going to have two positives. If I have a positive in the back and a negative in the front, I'm going to have two negatives. Okay. The catch is when you have two negative numbers, the shortcut is this negative tells you you're going to have one of each. So I'm going to have a positive and a negative. However, the one in the front is always going to be applied to the larger number. So for example, in this first one, since I have a negative in the back, I have a positive and a negative. However, since my positive is in the front, my larger number when I do my math is negative. I know it's a little confusing now, but as we go, it'll make more sense. This is what it looks like. So when you're factoring a trinomial, your ultimate goal is to get two binomials. Okay. In order to do that, you start with the first, so the product of C. Product of C is two numbers that multiply together that gives you the answer for C here. Your form should always be x squared plus bx plus c, always. So we're looking for two numbers that multiply to give you C. Those same two numbers have to add, so the sum of B, add together to give you what is B. This is what it looks like for numbers. So I have x squared plus 13x plus 30. When I do information like this, I'm going to work it out. And so I need to first find the product of 30, so two numbers that multiply to give me 30, and those same two numbers must add together to give me 13. Now, according to Pearson, they teach it this way. Create a chart or do some sort of table. Okay, I'm looking for factors of 30 that sum to give me 13. When you go through, you just start doing your math. So using the trick from the previous slides, since my positive is in the back and my positive is in the front, I know I have all positive numbers, so I'm going to just find products of positive numbers. So 30 times 1 is 30. 30 plus 1 is 31. That doesn't work. 15 times 2 is 30. 15 plus 2, 17. Doesn't work. Last one, 3 times 10 is 30. 3 plus 10 is 13. That applies to both. 3 times 10 is 30. 3 plus 10 is 13. It works. So when I go to write my answer, I write two binomials. I put an x in each because that's my firsts. And I put 3 and 10. Again, I already knew they were both positive, so I make sure they're both plus in the middle. Now, occasionally, it doesn't work out so pretty. So here's another one. Doesn't work out so pretty. All right, so we have x squared minus 6x plus 10. The concepts are the same. I'm finding a product of 10 and the sum of negative 6. Okay. When I go through, I do the same process. Negative 1 times negative 10 is a positive 10. Negative 10 plus a negative 1, negative 11. Again, because I have a positive in the back and a negative in the front, I know both of my factors are going to be negative, and that's why I put them as negatives. I have two negatives, 5 and 2 equals 10. 5 plus 2 is a negative 7. Now in this case, these are the only factors of 10. Nothing else multiplies to give me 10, which means none of the factors will add together to give me negative 6, which then give me a prime polynomial. That is my answer. So most of the time, especially on our tests, yours will work out pretty. I want to make sure you can do the math all the way. However, there are instances where it doesn't work, so then you get prime. Okay, there are no factors involved. Objective 2, factoring out the greatest common factor. So we talked about greatest common factor in a previous section. Now we are going to continue. Okay, so when we are factoring again, you're going to get a trinomial. Now, when we talked about factoring, all it is division. So you're going to ask yourself which number or which variable divides into all pieces. Now, when we divide, it must apply to everything involved. Okay, in this equation here, our greatest common factor is 3, which means I can divide 3 for every single piece, but I can't divide any m's because 60 does not have an m. So 3 is my only option. This is the same as dividing of what we talked about in chapter 5. So I do the division. So when I go to my next step, I do my division. So I'm dividing 3. 3 goes into 3 one time, so I have an m squared. 3 goes into negative 24, negative 8 times. 3 goes into negative 60, negative 24, I can't even talk, negative 20 times. There we go. I always put whatever I factored out in the front. Now in the previous section, this is where we stopped. We took out our greatest common factor and we put the rest of our information, all of our leftovers, in parentheses. However, since this section is factoring trinomials, you need to continue. So we need to find products of negative 20 that add together to give me negative 8. Because I have a negative in the back, I know I'm going to have a negative and a positive answer, and my larger number will be negative. So when I do my math, and it's just like the previous slides, I find the products of 20, so negative 10 times 2 give me negative 20. Negative 10 plus 2 gives me negative 8. I need to carry my 3 down. It must happen. So my final answer is 3 times m plus 2 in parentheses times m minus 10 in parentheses. That is factoring out the greatest common factor. So you divide, and then you do everything that we talked about in the first 2 slides. Last section. So section 6.4, this is factoring trinomials by grouping. Now we talked about a form of grouping in a previous section. This is another way to look at factoring, right? It's just another option. So in order to do that, you will have ax squared plus bx plus c. You will always have a coefficient in front of your squared in order to do factor by grouping. Okay, so in order to use the grouping method, here are your steps. All right, so step 1, factor out the greatest common factor if there is one other than the number 1. So just like the previous slide, how we factored out 3, if it's factor by grouping, you factor out the greatest common factor. Okay, you factor out 3. The resulting trinomial, okay, will be ax squared plus bx plus c. Okay, you find 2 numbers that are the product of a times c, whose sum give me b. I know it sounds confusing. As soon as we get to the numbers, it'll make more sense, I promise. Step 2, we write the middle terms bx by using the factors found in step 2, so our information here, and that's how we factor by grouping. So here's our information. I know it looks like a lot, but we'll get through it. So I'm given an equation, 8x squared minus 14x plus 5, and I'm asked to do it by grouping. There is no common factor other than 1. Okay, so 8 does not go into 14 or 5. 5 can't go into any of them evenly, so there's no greatest common factor. That's what I want to make sure, because if there's a greatest common factor, I'm going to do factoring with a greatest common factor, like the previous slide. Since there is not one, I can do factor by grouping. So in order to find 2 numbers whose products are a times c or 8 times 5, remember a times c, 8 times 5, and the sum of b, which is negative 14. So I'm looking for factors of 40, because I multiplied the 2, whose sums are negative 14. The steps from here on out are exactly like the steps we did previously. So I'm looking for factors of 40, because I have a positive in the back and a negative in the front. I know both of my answers will be negative. So I have negative 40 times negative 1. 41 doesn't work. Negative 20 times negative 22, negative 20 times negative 2 does equal 40, but it equals negative 22, doesn't work. Negative 10 times negative 4 does equal 40, and then they both add together and give me negative 14, which means, now that I have step 3, I write my negative 14x in my 2 answers. So negative 10 and 4. So 8x squared gets brought down. Okay. Instead of negative 14x, I'm going to put negative 4x, negative 10x, because those are the factors I found, and then my 5x gets brought down. Okay. Again, I know it's confusing. Just keep trying and you'll get there. Once I have a polynomial, now I do factor by grouping just like we taught in the previous chapter. So I pick two that are alike and I'm going to pull out the greatest common factor. So I know 4 and 8 can divide evenly, and I know they both have an x, and I know 5 and 10. So when I put them in, I'm going to factor out. Now I know that 4 can go into 4 and 4 can go into 8, and since they both have an x, I'm pulling out a 4x. 4x divided by 8x squared is a 2x. 4x divided by a negative 4 is a negative 1. Okay? Looking at my pieces, I know I can pull out a 5 from 5 and negative 10. So I pull out a negative 5. That gives me a negative 1 because I want my two negative 1s to match here. So 5 divided by negative 5 is a negative 1. Negative 10x divided by a negative 5 is a positive 2x. Since they canceled out, I write them once. So I look below. I got to stop moving my cursor so it pops up. As you notice below, I have a 2x minus 1 in parentheses, and then I have what I factored out. I have a 4x minus 5 in parentheses. This last step, this factor by grouping step, is the same as lesson 6.1. So if this is confusing, that's step 4, go back to 6.1, watch that video. It's the same thing. The only thing that's different is up here and how we replaced the bx with our two factored pieces. That's the only thing that's different when we're factor by grouping. Here's another one. I'm going to just push up all the steps so we can see. Factor by grouping. I look at my pieces. In this case, I can factor out a greatest common factor of 2, so I do that. I pull out a factor of 2. I do my math. 2 goes into 6 3 times, 3x squared. 2 goes into 2x 1 time, so I have a negative x left over. 2 goes into negative 20, negative 10 times. Okay, so now that I have my information, I can do the same factor by grouping. I know it sounds really crazy, but you can. So because I have my information and I still have a coefficient here, this is the catch, is I have a coefficient here, I do factor by grouping. So I find two numbers whose products of A and C give me the sum of negative 1. So I'm looking for 3 times negative 10, A times C, is negative 30, and I have to figure out what two numbers multiply. Well, two numbers that multiply, negative 10 and 3, negative 30, who equals negative 1. So when I do the math, when you work it out, you can do the table just like the previous one. If you need to go back and watch the video, show the table. I get a negative 6 and a positive 5. 6 times 5 is 30, so whew, that worked. Negative 6 plus 5 is a negative 1. It works. So instead of my b here, the negative 1, I replace my two factors, and then I do factor by grouping. All right, so I combine 3x times 6x. Again, if factor by grouping is confusing, go back and watch 6.1. Okay, it is explained there. Step 4 is 6.1. So the only thing that's new that you need to learn are these first two steps. These last two steps are things that you've already learned. As soon as you get over here on the base, as soon as you get two binomials that are the same, you combine them down. You bring out your factored or your leftovers and bring them down. You will always end up with two binomials. Always. I hope this is helpful. If you have any questions, don't hesitate to email.